Hello everyone. Today I am going to explain about the Unit 2 linear differential equations of second and higher order from Mathematics 2. Introduction about the higher order linear differential equations is an equation of the form d power ny plus p1 d power n minus 1y plus p2 d power n minus 2 into y plus so on pn y is equal to q of x. This type of equations are called higher order linear differential equations with constant coefficients. Why we called as with constant coefficients means here p1, p2 so on pn are constants and q of x is a continuous function of x. So that's why this type of linear equations are called ordinary linear differential equation of order n with constant coefficients. Here d is equal to d by dx. This is the operator to the derivative d by dx. So that's why we directly write in the operator form of an linear differential equation. The complete solution for the ordinary linear differential equation is y is equal to complementary function plus particular integral. So complementary function is denoted by CF or YC. Particular integral is denoted by PI or YP. So that's why we can write as complete solution y is equal to complementary function plus particular integral. Now, operator form of ordinary linear differential equation is, first you have to write the higher order differential equation. After that, whatever the function y is there, write outside, that is d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on pn into y is equal to q of x. So this will write as f of d into y is equal to q of x. Why we write it is f of d means here the d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on pn is a polynomial with d. So that's why we can write it is a function in d. So that's why f of d into y is equal to q of x, where f of d is a polynomial in d, where f of d equal to d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on pn, where p1, p2 so on pn are real constants. So this is our operator form for higher order linear differential equations, that is f of d into y is equal to q of x. Here solution is two types, so that's why we can discuss about the solution to the f of d into y is equal to q of x. So if the given differential equation in the form of f of d into y is equal to 0 means q of x is equal to 0, the complete solution y is equal to only complementary function. If the given differential equation in the form of f of d into y is equal to q of x, you need to write y is equal to complementary function plus particular integral. You need to remember these 2 points. If f of d into y is equal to 0, the solution is only complementary function. If the equation in the form of f of d into y is equal to q of x, the solution is y is equal to complementary function plus particular integral. Now we will discuss about auxiliary equation. What is the auxiliary equation? So auxiliary equation of f of d into y is equal to 0 is f of m equal to 0. That is m power n plus p1 m power n minus 1 plus p2 m power n minus 2 plus so on pn equal to 0, where p1, p2 so on pn are real constants, is called auxiliary equation of f of d into y is equal to 0. Means that for any higher order differential equation, first you have to write the auxiliary equation, that is f of m is equal to 0. If you observe one point, that is in the operator form of d we write d power n plus p1 d power n minus 1 plus p2 d power n minus 2 plus so on pn is equal to f of d. But here we are writing in the auxiliary equation in the place of d we are writing m, we get a auxiliary equation. Simply we can write the auxiliary equation to the given higher order differential equation and find the roots of the given differential equation by using auxiliary equation. That is, auxiliary equation f of m is equal to 0 is a polynomial equation of degree n, because of it start with m power n, so that's why it is a degree n. It will have n roots, m1, m2, so on mn. If you take any quadratic equation with the square, you get a 2 roots. If it is cubic equation, you get a 3 roots. Same as here, auxiliary equation with order n, so that's why you can get the n number of roots. So next, how to find the roots and what are the complementary function based on the roots to the given differential equation, next we will discuss. So that is finding complementary function. So after finding the roots, we can go to the types of roots. You can write complementary function. First case is if roots are real and distinct. So the roots are real and all are different. That is, roots are n number of roots. So that's why we can write m1 not equal to m2 not equal to so on not equal to mn. All the roots are real and distinct. The complementary function equal to c1 e power m1x plus c2 e power m2x plus so on cn m e power mnx is the complementary function for roots are real and distinct. Second case is if roots are real and equal, all the roots are equal, that is m1 equal to m2 equal to so on mn. The complementary function equal to c1 plus c2x plus c3x square plus so on cn x power n minus 1 into e power m1x. We can take only one root because of all the roots are equal. This is the second case. Next, third case, if roots are complex, means alpha plus r minus I beta form. If m1 equal to m2 equal to alpha plus I beta or alpha minus I beta, means generally we called as alpha plus r minus I beta, then complementary function equal to e power alpha x into c1 cos beta x plus c2 sin beta x. Next one, case 4, that is if roots are complex and non-repeated. So that is m1 m2 equal to alpha 1 plus I beta 1 or alpha 1 minus I beta 1. Means first two roots are alpha plus r I beta, and second two roots also it is in the form of complex alpha plus r minus I beta. If it is repeated, we can use the repeated rule, but the roots are not repeated with complex, so that's why you need to write carefully. Complementary function is e power, first roots e power alpha 1x c1 cos beta 1x plus c2 sin beta 1x plus e power alpha 2x for second roots e power alpha 2x c3 cos beta 2x plus c4 sin beta 2x. So this is for different complex roots, now means non-repeated. In case of if it is repeated, simply you can write e power alpha x c1 plus c2 x into cos beta x plus c3 plus c4 into sin beta x. That is one of the complementary function for complex and repeated. Next one is, that is about the particular complementary function. Now we will discuss about the particular integral. So how to find the particular integral to the given f of d into y is equal to q of x. That is particular integral in some special cases, means depending on the q of x we can find the particular integral to the given function. That is pi of f of d into y is equal to q of x when q of x is equal to e power ax, where a is a constant. This is first type to find the particular integral to the given f of d into y equal to q of x and q of x is equal to e power ax. Next case is particular integral of f of d into y is equal to q of x when q of x is equal to sin bx or cos bx, where b is a constant. This is the second case to find the particular integral. Third case is particular integral of f of d into y is equal to q of x when q of x is equal to x power k, where k is a positive integer. So these two are the first three cases to find the particular integral. So next we have three more cases are there, that are particular integral of f of d into y is equal to q of x when q of x is equal to e power ax into v, where a is a constant and v is a function in x. So here a fourth case for particular integral is q of x is equal to e power ax into v. V is a function in x, but it has a condition. We will use this method to find particular integral when v is sin bx or cos bx or x power k or a polynomial of degree k. Means in the place of v, we have sin, cos, x power k or polynomial in x, then we can use this method. Next, particular integral of f of d into y is equal to q of x when q of x is equal to x power m into v. It is e power x into v. Next one is x power m into v. M being a positive integer and v is any function of x. So we can write v is any function of x. Here also we have one condition. If v is sin or cos, then we can use this method x power m into v. So v must not be x power k form, v must be sin or cos. We can use this x power m into v form. So last method, if no one means that match with q of x is not matching with all five methods, then we can use the general method, that is general method of finding particular integral. Pi of f of d into y is equal to q of x when 1 by f of d is expressed as partial fractions. So finally, if q of x is not matching with the above five methods, then we can use the general method, last method, that is 1 by f of d, right in the partial fractions. These all about the particular integral. First we will discuss the example on particular integral of f of d into y is equal to q of x when q of x is equal to e power ax. So first example is, before going to example, how to find the particular integral if q of x is equal to e power ax. So particular integral of f of d into y is equal to q of x when q of x is equal to e power ax, where a is constant. So let f of d into y is equal to, what is q of x? E power ax. So standard form of particular integral is equal to 1 by f of d into q of x. Q of x is equal to e power ax. In the place of q of x, we have e power ax. Simply you can substitute d is equal to a. Whatever the x coefficient is there, that value substitute in the d. We get f of a value. If f of a is not equal to 0, directly you can write a formula, particular integral is equal to 1 by f of a into e power ax. This is the first case. If f of a is not equal to 0, particular integral equal to 1 by f of a into e power ax. So second case is, let f of a equal to 0. In case of f of a equal to 0, you need to write f of d in the form of d minus a whole power k into phi of d. Because of d minus a is a factor of f of d. If a is a root repeated k times for f of a equal to 0. If f of a equal to 0, if it have d d minus a factor with repeated k times, then we can write f of d is equal to d minus a whole power k into phi of d, where phi of a not equal to 0. So particular integral standard form you have to write it 1 by f of d into e power ax. F of a equal to 0, then you can write f of d as 1 by d minus a whole power k into phi of d. You should remember which factor is having d minus a, means that root a is there, that is considered as d minus a whole power k. Remaining factor is considered as phi of d. So after that, write the particular integral is equal to e power ax by phi of a. So how to find the phi of a? Substitute a in phi of d. D is equal to a. You can substitute it. You can get the phi of a, e power ax by phi of a into x power k by k factorial. K means order of the root, means whatever the factor d minus a having the power, that power is equal to k. So that's why x power k by k factorial if phi of a not equal to 0 and f of a equal to 0. In case of f of a equal to 0, you can go to the second case. You can equate f of d equal to d minus a whole power k into phi of d. Finally, you can write the particular integral is equal to e power ax by phi of a into x power k by k factorial. This is a formula. Next example, solve d square y by dx square plus 4 dy by dx plus 3y equal to e power 2x. So this is a given second order differential equation. First you need to write in the operator form. What is the operator form? D by dx is equal to capital D, we know that. So that's why we can write in the operator form is d square plus 4d plus 3 into y equal to e power 2x. First you need to find the complementary function. After that you can go to the particular integral. Complementary function, how to find the complementary function? We can find the complementary function by using the roots of the auxiliary equation. So that's why first we need to write the auxiliary equation is f of m is equal to 0. What is f of m? M square plus 4m plus 3 equal to 0. Simply you can substitute in the place of d m, we get the auxiliary equation, that is m square plus 4m plus 3 is equal to 0. So find the roots by using the factorization method, that is m square plus 4m write as 3m plus 3, because of here m coefficient is 1, here m coefficient is 3, 3 into 1 is 3, so satisfies the constant, and 3 plus 1 is 4, here satisfies the m coefficient. So that's why we can write with m square plus 3m plus m plus 3 equal to 0. So m into here, from these two terms m common, m into m plus 3 plus here from these two terms we can common 1 m plus 3 equal to 0. So totally m plus 3 is common, m plus 3 into m plus 1 equal to 0. We get two roots, m is equal to minus 1 and m is equal to minus 3. So the roots are real and distinct. So that's why the complementary function is c1 e power m1x plus c2 e power m2x. Only we have two roots, so that's why stop at m2x. So here m1 is equal to minus 1, m2 equal to minus 3. So complementary function equal to yc equal to c1 e power m1 value is minus 1, so minus 1 into x minus x plus c2 m2 value is minus 3 e power minus 3x. So this is about the complementary function. Next, going to the particular integral. So write the formula for particular integral. Standard form is 1 by f of d into q of x, that is 1 by f of d into e power ax. So you write 1 by f of d. F of d is d square plus 4d plus 3 into e power 2x. If you comparing with e power ax, a value is 2, and here one simple small logic, all the terms are positive terms, so that's why you need to get f of a value is positive and it is a constant, it is not equal to 0. So that's why simply you can find the f of a value. F of a is equal to a square plus 4a plus 3, but a is equal to 2, substitute it, 2 square plus 4 into 2 plus 3, that value is 15, it is not equal to 0. Simply you can write the particular integral is equal to 1 by f of a into e power 2x. F of 2 value is 15, so that's why we can get particular integral is equal to 1 by 15 into e power 2x, that is equal to e power 2x by 15. So finally you should write the general solution. Y is equal to complementary function plus particular integral, that is y is equal to c1 e power minus x plus c2 e power minus 3x plus e power 2x by 15. So this is our required general solution of higher order, means second order differential equation. Second example is solve d square plus 6d plus 9 into y is equal to 2 e power minus 3x. So first you have to write the auxiliary equation. Auxiliary equation is f of m is equal to 0, that is m square plus 6m plus 9 equal to 0. So it is in the form of m square plus 2 into 3 into m plus 3 square, means a square plus 2ab plus b square form. So that's why I directly write a plus b whole square, that is m plus 3 whole square equal to 0. So we get the roots are m is equal to minus 3 comma minus 3. Roots are real and equal, so that's why the complementary function is c1 plus c2x into e power m1x. Here m1 equal to m2, so value is minus 3, so that's why we can write minus 3x. Next, going to the particular integral. Particular integral is equal to pi equal to 1 by f of d into q of x. But q of x is equal to 2 e power minus 3x. So here 2 is a constant value right outside, and 1 by d plus 3 whole square. Because of f of d, write in the form of d plus 3 whole square e power minus 3x. Here clearly we can observe, if you substitute d is equal to a, that is minus 3, we get the value is 0. So that's why we can go to the second case. Here already substituted the a value, a is equal to minus 3, f of d is equal to f of a equal to a plus 3 whole square, that is minus 3 plus 3 whole square, value is 0. So that's why we'll go to the second case. In the second case, f of d write as d minus a whole power k into phi of d. But here only one factor is there. How to write phi of d? So you can multiply the function with 1. So that's why phi of d is equal to 1, and d minus a whole power k is the factor with d plus 3 whole square. Because of d minus of minus 3, we get d plus 3 whole power k. K value is 2. So that's why we can write k is equal to 2, phi of d is equal to 1, and phi of a is equal to also 1, because of here there is no value for d. Here there is no need to substitute the a value in phi of d, only phi of d value is 1, so that's why phi of a is also 1, and the formula for particular integral equal to e power ax by phi of a into x power k by k factorial. Again I am explaining this. F of d write as d minus a whole power k into phi of d form. It should be the factor with a, so that is d plus 3 whole square, d minus of minus 3 whole square form. So that's why k value is 2. So phi of d is equal to 1. So write the formula for particular integral with f of d is equal to d minus a whole power k into phi of d if f of a equal to 0, that is e power ax by phi of a into x power k by k factorial. Here already 2 is there, right? 2 into e power minus 3x, because of a value is minus 3, e power minus 3x by phi of a value is 1 into x square by 2 factorial. K value is 2 no, so that's why x square by 2 factorial. 2 factorial value is 2, 2 cancel, x square e power minus 3x is our required particular integral. Finally, you can write the general solution is y is equal to complementary function plus particular integral, that is y is equal to c1 plus c2x e power minus 3x plus x square e power minus 3x. So in this method I will give the small alternative method, that is if you are not able to do the f of d in the form of d minus a whole power k into phi of d, simply you can write particular integral equal to 1 by f of d into q of x 1 by d plus 3 whole square 2 e power minus 3x. If you find f of a that value equal to 0, multiply by x power k to the numerator. So means that our root is repeated how many times? 2 times. What is our root? Minus 3. A value is minus 3. So root of the equation is minus 3. So that's why d plus 3 is repeated 2 times. So that's why multiplying by x power k to the numerator means x square to the numerator, and differentiate denominator k times if root is repeated k times. So means that here d plus 3 is repeated 2 times, that d plus 3 is with the root minus 3. So that's why you can differentiate 2 times. So simply you can multiply the numerator with x square because of k value is 2. So that's why it is multiplying with x square, and differentiate denominator 2 times. If the root is repeated 3 times, you can multiply with x cube, and denominator differentiate 3 times. So in case of k value is 1, root is repeated only 1 time, you can multiply with x and denominator differentiate only 1 time, that is the root is equal to a equal to minus 3, it is repeated 2 times, k value is 2. So simply we are multiplying, 2 already constant is there, numerator multiply with x square, denominator differentiation f of d is equal to d plus 3 whole square. So x square differentiation is 2x. So here first order differentiation is 2 into d plus 3 into d plus 3 derivative is 1. Next f double dash of d, because of we need second order differentiation, that is 2 is a constant, d plus 3 derivative is 1. So 2 into 1 value is 2. Substitute here, we can get 2 into x square e power minus 3x by 2. Again I repeat it, the numerator multiply with x power k, denominator differentiate k times if the root is repeated k times. So that's why we can cancel 2 to particular integral is equal to x square e power minus 3x. This is about the first method.